Good evening, everyone. And tonight we're going to have a look at some access lists. Just a brief explanation of access lists. I've been having a look at some of the forums online, and a lot of people have actually been having difficulty with this, and it's people that are quite new in the industry, learning, trying to figure out how access lists and all of that works. So I'm just going to shed some light on this. Hopefully it helps you guys out. Just want to make this picture a little bit bigger. This is our topology for tonight. Sorry, I'm rushing through this a little bit and talking a little bit quickly. I want to try and keep this as short as possible so I don't bore you guys to death, because there's actually quite a bit of information to take in. So this is a topology that we are working with tonight. We'll have the inside network, a firewall, and then the outside network, which is outside router and inside router, and the normal firewall. The little cloud with the management, that is of course how I will be managing the firewall. We've also got a little DMZ hanging off of here, which I haven't added to this specific overview. Okay, so please take note of this. Going forward, I will be referencing back to this quite a bit. So let's have a look at the ASA quickly. These are the configured interfaces that we have at the moment. As I mentioned, the DMZ, we've got the outside network, and we've got the inside network. So to understand how access lists work, you also need to understand how your interfaces work, especially on Cisco ASA. So let's have a quick look at the interfaces. Show run if my fingers want to work. Interface, cool. Once again, guys, if you have syntax errors, or you're not too quite sure what is supposed to happen or how to complete the command, you don't always need to type fully out the command. Just tab it out and you'll get the options that you need to finish the command, or use the question mark to see whether you are on the right track or you're missing an option or something like that. Just as a quick example on how to configure stuff. Okay, so let's have a look on the inside interface, which is gig01. Over here inside, there's the IP address. Down here we've got gig01 name if. Name if is quite important because this is associated with a security level. By default, inside is 100. 100 is the highest level, and it is the most trusted kind of level that you get within the network, because of course, yes, you trust your own network. You don't trust a DMZ, you don't trust an outside network, you trust what is inside of your network. It's also wrong to think that way, but this is how the ASA works. In today's security world, we've got a zero trust model that we're working on, that we just don't trust anything. But for now, let's focus on the interfaces. So this is your inside, and it's got 100 level. Outside, of course, it's got 0. Then we've got the DMZ, which has got a level of 50, which is like half. So to explain how the security level actually works, is almost like a waterfall effect. Let's say the top of the waterfall is 100, and at the bottom of the waterfall it is 0. Anything coming from top can go to bottom, but of course, yes, bottom cannot go to the top. In this case, traffic coming from the outside interface can speak to the inside interface, or outside network speaking to the inside network. This is possible, but this is done via access lists that you apply to the correct interfaces. For instance, you need to understand the flow direction of your traffic on the interfaces. For instance, if you want to permit, this is not something that I advise you to do unless you've got a specific business case for it. If you have traffic coming from the outside interface and it needs to speak to the inside interface of your firewall, you would apply the incoming traffic from the outside to the outside interface. if you have traffic coming from the inside network, going to the outside, you'd apply the access list on the inside interface. So closest to the source. So now that we've got an idea of where to apply the interfaces and how apply access lists on which interfaces and how the interfaces actually work in the security levels, let's move on to types of access lists. So there are actually quite a few. Let's have a look on this firewall here, show access list. So this is a little bit gibberish at the moment. I'm going to take some of this out and just copy it onto ultra sophisticated notepad. Okay, let's have a look here. Okay, paste this in here, take out all the gibberish. It's not really required, not really required. Okay, let's have a look here. I'll explain everything nicely now. Okay, so you have the access list, you have the name of the access list and which line it is applied to. A firewall, whether it's iOS or ASA based, or any firewall for that matter, always reads from top to bottom. That's why you've got line 1, line 2, line 3, line 4. The first line will always be read first. At the end of the list, you always have an implicit deny rule. A rule meaning that doesn't matter what kind of traffic or what if the traffic comes through and it doesn't hit any of the access lists that you have specifically specified, it will hit the deny rule, the implicit deny. It will stop the traffic. This is to lock down your environment, and this is why access lists are so important, is that you need to granularly specify which traffic is allowed to come into your network or leave your network. Coming from the inside, going to the outside, or the DMZ coming to your inside network. It's very, very important. This is probably one of the topics that are underestimated quite a bit. And on the access list, you can add on logging information as well for troubleshooting purposes. For instance, on this specific rule, we are logging on an informational level. And each access list got a hit count as well. So most of these rules have actually got a 0 hit count, and I'll explain now why as well. Because if you remember, like I said, the most accurate the most accurate rule hits and the traffic passes. It doesn't need to read any further unless it hits the implicit deny at the end, which means that the traffic is not allowed. So for instance, here we've got access list, which is the name, which is the inside. So it means that traffic from the inside, it's applied on the inside of the firewall. If you refer back to the picture, it would be on gig 01. This is the second line. This is the type of access list is extended access list, and this access list is to permit traffic, and it is to permit IP-based traffic, IP protocol stack, and this is from anywhere on the inside network going anywhere on the network. We're going to log that traffic, and you can see that it is quite a broad rule, so a lot of traffic will match it, and that's why it's got a hit count. I was testing this lab before we were doing this, so I just made sure that everything was working, and hence the hit counts. So for instance, let's have a look here on the outside. So we've got an access list on the outside, and it's the first rule, and it's an extended type. It is to permit ICMP type of traffic anywhere from the outside. Please don't ever do this on a production network. Very unsafe. This is only for lab purposes that I'm doing this. This is to explain to you guys how access lists work. Please be very, very, very careful what traffic you apply or what traffic you permit on your network. Be very, very, very careful. So this is ICMP from anywhere on going to interface inside. So you can specify like source destination IP based specific host IP addresses, or you can specify entire network ranges as we've done here above. Or you can specify an actual interface, which would be the inside interface, and we're going to log that interface. We're going to log that informational logging. We can send it off to a syslog server or keep it locally stored, which won't last very long if you've got a very busy firewall. So you guys kind of get the idea. So you say, for instance, here's an access list. Let's use this one because this access list is more common. You're going to see a lot more of this on a day-to-day basis on a firewall. So here we've got permit, we've got TCP type of traffic coming from this source network. This is a source network. If it was a specific host, it would say permit TCP host IP address to whatever. But now we are allowing a network to connect to a destination network, and what we are allowing is HTTPS traffic, port 443. Now, when you apply these rules, you can say equals to 443 or HTTPS. The firewall will accept it. So here's our hit count. It doesn't have any hit counts of it, of course, because it's just a lab. I'm just showing you guys what the access lists look like. And this is the hexadecimal value identifier of this access list. So really, this doesn't mean much. If you want to go and write a firewall rule to be applied somewhere, please usually try and copy out a access list rule and copy it into a notepad somewhere like this one here. So we can take that one out. You remove the line identifier. Copy and paste it. Now, when you are outside of the, especially on command line, you're out of the network. You're not going to interfere with anything. You can edit and make the changes, and we can even change this to, let's say, host 192. 192.168.100.1 going to that network, because now we're specifying a host to go there equal to HTTPS. We can even say port 80, and I'll actually show this nicely now. When you take this, we copy this, we'll quickly restart this one because it is timed out. My super secret password that no one will ever be able to crack. Okay, we'll go into configure terminal, and we'll actually go ahead and paste this nicely. See, now you don't make any syntax errors. If you do not know what you want to do, you can just hit the question mark and it will actually give you like a list. So for instance, here you've got the actual port numbers. Enter port number 1 to 6,000 or 65,535. That is actually the entire port range which is available. Or if you actually know the actual protocol, for instance, here we've got HTTP, HTTPS, which is port 80 or 443, just as an example. So we are going to add port 80. Now please note, HTTP and port 80 is the exact same port. Have a look now. We're adding that in there. So now that it's been added in there, let's do a show access list pipe down include inside. So we only want to see access lists which got the name inside, and we'll have a look here. This is interesting. So there's our access list added to the bottom of the list because there's already been rules added to the top of it, so it's reading from top to bottom. So for instance, here we've got the host, exactly how we typed it out. Going to this network, and it's equal to www. We added previously, just go back here, we added previously port 80, and over here we've got HTTP, and all of a sudden it's adding www. This is nothing to worry about. This is simply how the ASA has been coded to accept rules and to let you understand. This is also from a human-based point of view. If you're reading this quickly on the command line, to see the difference between HTTP and www. It's quicker to see that because your eyes won't quite as quickly see the difference between HTTP and HTTPS. It's easier to see it this way. It's just how Cisco really configured or coded the ASA to work. So most important things: source, destination, port. That is how it reads. It reads from source to destination, what port you want to allow. It's very, very important. Um, Also, you can name your access list whatever you want to access, or whatever you want to make your access list. If you want to make it Superman access list and apply it to any interface access list, you can go right and do that. But best practice is to actually specify on which interface you are actually really applying it. You can take an access list and you can add as much rules to an access list as you want, as long as you don't add so much access list that you actually drain system resources. Once again, try and use granular rules to permit specific traffic to secure your network. Don't go and add in IP any, going from any source to any destination on any port. That is not. Otherwise, the function of the firewall is just null and void. It's not how it's supposed to work. You're supposed to lock down your network. So yes, do pay attention to source and destination, how it works, where the names are, where you apply it. This is very, very important. So for instance, just to let you to show you guys, so we've got the IP any here, and we are actually going to hit this rule over here, which is an IP any. Because it is line 2 and it's very broad and more, it covers already the specific traffic that I'm going to generate now, instead of this one over here. If you had to take this rule and put it on line 2, this one for the specific rules, for the specific traffic that we're going to generate from this very source to this very destination, then this one would take preference over that one. Reads from top to bottom, just remember that. So let's quickly bring up the two routers. So to show you guys the configuration that we've got here, show IP interface brief, and this is the interface that we've got going here. Show IP interface brief, and that is the interface over there. So let's quickly do the pings. You can see it's successful over there. Do the pings over there. Also, just to show you guys, if you want to lab this up, show IP root, because it's iOS based device. You can see that there's a static route that I added that points the traffic to the next hop, which is the firewall. The firewall does because it's only one route, it will know where to send the traffic because it's aware. It's a directly connected network. Show IP route. And we've got the same over here. So that's why the traffic is working. We've got the rules applied to it. Let's quickly have a look at the ASDM so that you guys can see what the rules look like on ASDM. Running a little close here on time. Launch ASDM quickly. So continue. Come on. Okay. So what we've got here at the moment is configuration. Here's the interfaces. We'll have a look. Configuration, interfaces, interface settings. You get the inside, outside DMZ. security level, you can see 100, 0, 50 with the IP addresses. Let's quickly have a look at the rules here. Okay, for instance, here you can see that specific rule that I spoke about, which is the the services IP, and you can see that the rule count is now 23. Let's quickly have a look over here. The hit counts were 11, so we can restart this quickly. So access list include inside, and we'll see here that it's now 23, just like it is on the ASDM. So 23, 23, so this is coming from the outside back into the inside. That's the two tests that we did, and we can verify that everything's working there. It's got logging information here, so if you've got like a syslog server or whatever, you can take those logs, send it right off, and if you later on need to do troubleshooting, you can do that. Guys, this is the basics of, this is very basic overview of how access lists work, how they look like, where to find them on ASDM, and how they work on Cisco CLIs. You remember that it's not just on ASAs that you can do this on iOS devices as well. I just quickly wanted to show you guys how this works and best practices and all that. Keep it granular, keep it specific, don't allow everything. Be cautious about what you allow. Be aware of what you allow, because you can put yourself at risk. Please be careful. Never do this on a live environment. Please always use a test environment, such as a lab at home or a lab at your office or something like that. Be very careful about what you do. Always get approval before you do something, especially on a live environment. Be very careful. Guys, I hope that you've enjoyed this video and that you've learned something. Please give this video a thumbs up, and please subscribe to my YouTube channel. I know that I haven't been posting as often as what I said I would. I do apologize for this. It has been a little bit busy here on my side, but I hope to bring you guys some more content very soon. Have a great day further. Cheers.